Hi, this is Aaron Lewis from Franklin Maths. This lesson is on the binomial distribution, which is part of the AS course, and also on the full A level for the new A level maths. Okay, so first thing we're going to do is we're going to look at three scenarios and look for any common traits. So I'm going to show you them. Feel free to pause the video, think about it, write about it. Doesn't really matter. So there are your three scenarios. Have a look at them, see what you can see in common. Okay, so some of you might say, well, Aaron, they're all to do with probability. Would you be absolutely right? But let's see if we can dive a little bit deeper here. Just change my pointer to pen. So, things are in common. We have got two outcomes in each scenario, what I'm calling success and failure. So with this coin scenario here, we're going to say heads would be success, tails is failure, because we're trying to obtain heads. Okay, I don't mean success as in doing well and failing as in not doing well. I don't mean it like that. I mean in terms of what we're trying to achieve. For question 2 here, scenario 2, sorry. The two outcomes in this case is hitting the bullseye, not hitting the bullseye. There's nothing in between. And for the bottom one here, obtaining a blue counter would be a success. Not obtaining a blue counter would be your failure. Okay, so each one has two outcomes, and all these are traits of the binomial distribution. Now the trials are independent. Now I know in real life not all things are independent, but for argument's sake and for today's lesson, they all will be independent. So flipping a coin, each one doesn't affect the next one. This one he actually says it in the question. If it doesn't say it, then that might be an assumption that you make. There is quite a lot of explanation and reason marks in this course, so that might be something you have to add into your question. And this one down here, again, these are going to be independent because we are replacing them. Okay, so independent trials. So if you think about a tree diagram, you multiply this across. I know some of you just done a little section on independence. We've got a fixed number of trials. Okay, so this time on here, I'm flipping the coin 10 times. Here we're having 25 attempts, and here I'm having 20 picks. Now on the old course, there used to be something called the geometric distribution, where you just sort of played the game until you hit the desired number. That's not in the course anymore, which is a bit of a shame. But on the binomial here, we do have a fixed number of trials. And the final thing is the probability of success is constant. Okay, so those are the things that you guys need to know. However, when you're working on exam questions, you must put each one of these in context. So, for instance, if we're talking about independent trials for number 2 here, we'd say the throws don't affect each other. Okay, or even for this, for fixed number of trials here, talking about number 3, we'd have to say, well, he's only going to do 20 picks, so make sure you always put them back into context. Okay. Okay, so this is what needs to go into your notes. So the conditions for the binomial distribution, you'll get a lot of exam questions as well asking about, what conditions need to be satisfied, what are you assuming. Make sure you know these inside out. So the first one, two outcomes, success and failure. Okay, the trials are independent. Each one doesn't affect each other. It's the same thing. Okay, but try and stick to independence. Again, as I say, keep putting it back into context of the question. We have a fixed number of trials, and the probability of success is constant, and therefore the probability of failure is constant as well. And the way we write it on the page is this. Now, a lot of you will be brand new to this. So x in this case would be what we're sort of measuring. Tilde in this case means approximated by. The b means a binomial distribution. N here is the, I'll get my pen work in a second, is the number of trials, and P here is the probability of success. Just the T out there. There you go. Apologise for that. So yeah, this is how it's going to be written. And if this looks unfamiliar to you, or you don't know, have a clue what this means, don't worry about it. It's just a way of writing something. It's just a mathematician's lazy way of writing. X is approximated by the binomial distribution. This is the number of trials. This probability. We know we like to have nice, concise ways of writing things in maths. Okay. So what I'd like to do now is to complete question 1 from exercise 21C. Pause the video, have a go at it, mark it. Any questions, send me an email or give me some feedback on Google Classroom. Okay, moving forwards ever so slightly. So what I'm going to look at now is calculating probabilities with the binomial distribution. Now I'm going to be using the calculator initially, and then I'm going to show you the formula and where it all comes from. Okay, so this will be really weird for a little bit. Don't worry about it. We'll master the skills, then we'll put it into context later on. Okay, so here we go. So I've got a binomial distribution here. I've got 10 trials. And the probabilities of success, whatever this may be, is 0.4. So I'm just going to write that down. So that's n there. And p. Don't get them mixed up. NP. They're alphabetically, so it should be easy to remember. So we're going to try and calculate the probability that x is equal to 2. So me obtaining 2 wins or something like exactly 2 wins. So if we say something like the probability of me winning a football match or my team is 0.4, I'm going to have 10 matches. They're all independent. What's the probability that I win exactly 2 matches? Okay, so I'm just going to grab the calculator and I'll show you where it all comes from. Okay, so I pulled up the calculator for you. So we're going to go into stats up here. Now we're going to go to dist. This is a binomial distribution. Then we're going to click binomial. Now we've got to have a little look here of what exactly we're doing. So we've got BPD and BCD. Now the BPD allows you to calculate probabilities. That's what it's equal to. So I'm just going to jot that on there. BPD is for when it's equal to. Okay. So BPD, we're just going to fill in. So we're not using a list. So if you press list there, it tries to calculate from a list. We're not using a list. We're using variable data, which is how this is written. Okay. X in this case is 2. Okay. Because it says that X is equal to 2. The number of trials is 10. And the probability of success, in this case 0.4. Press the equals button. And there you go. 0.1209. So 0.1209. As I say, armed with these new graphical calculators, really nice, easy to do. So anything that's BPD, we're going to be using. So anything that's equal, sorry, we're going to be using BPD. Now there is a BCD button. Now this particular calculator is a lot better than some of the older versions. So this is the CG50. If you are using one of the other models, you'll need to go and have a look up. Go and look up how to work it out, because it always does 1 minus. Okay, it always calculates probability downwards. If there's a desperate need for that, I will put some videos on about that. Okay, but I would really recommend paying a bit more money, getting this calculator. It will save you so much time for doing something like this. Okay, so what the calculator is going to do for B, it's going to get the probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, probability of 5, and add them all up. Now we could do that individually using the BPD button, but that would just take far too long. So we're going to go back on the calculator, back on dist, back to binomial, but this time we're going to go to BCD with a C meaning cumulative. Okay, variable data again. Now if you think about it, what was the lowest number here? This is effectively saying, I'll just pull my calculator away a second. This is effectively like saying the probability of 0, because we can't have a negative amount of wins or successes. This is effectively the same as saying that. Okay, and when you've got these two little equal bits on your inequalities, your calculator will work with those, and I'll show you what I mean now. So here's the calculator. So my lower is 0. My upper is 5. 10 trials again, 0.4. Press equals, and there we go. And that is then equal to 0.8338. Okay, so let's just think about this again in context. So probability of my football team winning a match is 0.4. I have 10 matches. What's probability that I win 5 or less matches? Fairly good chance. Okay. So now this one here, what I'm going to do is I keep saying to your calculator will calculate when you've got these equals bits on here. So I'm going to change this into one of those equals bits. So if something's greater than 2, that's surely the same as something greater than or equal to 3. Okay. Now in our case here, what's the maximum number of wins you can have is going to be 10, isn't it? So in this case here, 3 would be my lower, and 10 would be my upper. And if you think about what we've just done there, I want the probability that I win more than 2 matches. Well, it's all the way from 3 to 10. I can't win more than 10 matches. It won't make any sense. So I'm just going to bung it through the calculator again. Again, notice how I change the question to get the equals parts and the inequalities, and I can just bung it through. So here we go. Exit. My lower this time is 3. Upper is 10. And so it's 0.8327. 0.8327. Okay. This one here, look, that's the same as one above. Okay, notice it's the same question but written slightly differently. Just watch out for that. Make sure you can convert these. With binomial, it is a discrete distribution, so it goes 1, 2, 3, 4, 5, 6. You can't have 2.5 wins or anything like that. Won't make any sense. So this one's nice and easy for me. 8, 3, 2, 7. Right, this one here then. So we know it's easy to bung in the calculator if you can get an equals part on the inequality. So probability. We've already got the 3 in there, and there's the equals part in the inequality, which is quite nice. Now less than 5 is the same as less than or equal to 4. So we could use the BPD button and go 3 and 4, but it's so much faster to just use that BCD button and calculate it. So straight back on it. 3 and the upper's 4. So the chance of me winning 3 or 4 matches was, and I've lost my calculator, there is 0.4658. 0.4658. And the last one down here then. So I want the probability that I win more than 1 match, but win less than 5. Well, to be greater than 1, well, that means it's going to be equal to 2 or less. Greater than or equal to 2. And if it's going to be less than 5, that means it's less than or equal to 4. Okay. So it's fairly easy to do once you spot what's going on. On your worksheet, I would recommend for first part to go through each question and make sure they've all got the equals bit on the inequalities, and then you just type it into your calculator. It's really, really easy to do. So grab my calculator a second. I want to come over. There it is. So exit. Still using the same number of trials and probability. So my lower in this case is 2. Upper is 4. And 0.5867. 0.5867. Okay, and the idea is with this part of the work is just to get you guys mastering that calculator use. Don't put yourself at disadvantage in the exam or any test. Pick up the calculator and get on with it. Okay, so could you complete question 2 from exercise 21C? It is fairly easy to get along with. It says exactly like my examples. Pause the video, have a go, mark it, and send me any feedback if you need it. Thank you. Press play when you're done. Okay, so I need to show you where the binomial formula comes from. That's part of the course. Now, if you did A-level maths a few years ago before the new spec came in, before with these really nice calculators, you would have had to do most of this by hand. So let's have a look. So just have a look at the scenario. We've got a four-sided spinner, 4 different colours. I'm going to spin the spinner twice. And what's the probability that I obtain yellow on both spins? So this is like a bog standard GCE question. I believe actually this is down at Foundation now. Okay, but how would you approach that question? What would you do? I'm hoping you would say something like this, Aaron. I would draw a tree diagram. I mean, you don't have to. I mean, this one's fairly simple, but that would normally be the approach. Now, I've got yellow because I'm trying to get yellow. Again, notice I've got 2 outcomes, success and failure. That one would be a quarter. And down here, this would be 3/4. Now, notice the notation I'm using. I'm using y dash for not y. Okay, it's just quicker, more efficient. I could, again, just get used to seeing things you're going to see in your exam. So, quarter, 3/4, quarter, 3/4. I know lots of you know how to do this. So probability that I obtain yellow, well, that's just going to be a quarter times a quarter, so it's going to be 16th. Okay, slim chance of happening, but there is a chance. Okay, now, if you were lucky enough, you'd have had one of those 3-spin ones at your GCSE. Now, obviously, there's a bit of a problem now, because what happens then if I'm going to spin it 10 times? That tree diagram is going to be absolutely massive and extremely difficult for me to cope with. So let's have a look. There you go. So there you go. So I've changed the scenario now. I've kept the spinner with the colours. I spun it 3 times. And this time, what the probability that we obtain yellow exactly twice. So I'm looking for yellow. Okay. As you can see, even my skills on the computer have really struggled to make some of this. So let's have a look. Whereabouts have we got yellow? Okay. So there's one way here. Yellow. Not yellow. Okay, which is going to be a quarter times a quarter times 3/4. I'm just going to write over at the side here what it was. So that was yellow, not yellow. Any other ways of it happening? There's one here, which is going to be yellow, not yellow. And again, we've got a quarter times 3/4 times a quarter. I know lots of you are really good with this, but don't worry about it. I'm just going to explain the formula very quickly. And then last one then is going to be, handwriting's going all over the place, not yellow. So it's going to be 3/4 times a quarter times a quarter. Now, what do you notice about these formula? Yes, they're all the same. You've got the commutative property multiplication there. But there's a couple of things I want you to spot. Now, first of all, is that on each one we've got 2 of the successes. So on each one, I get a quarter squared, and I also get 3/4 to the power of 1. Okay. Now, how many different outcomes are there? We've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got 8 different outcomes. Okay. So we've got 8 outcomes. Now, if you look to this, and I could get you to do this, we could look at the probability of getting yellow, 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 which is 1. Probability of getting a not yellow, and then we could work from there. But you'll end up with the binomial coefficients. Now, if you have a look here, I've got 3 different ways of this happening. So I'd have 3 times a quarter squared times 3 quarters to the power of 1. Now, where does that 3 come from? Well, it comes from 3 choose 2. If I wrote out the all of these outcomes, so probably we're getting 1 yellow, 2 yellows, 3 yellows, 4 yellows, you'll find it's the third line of the binomial. So in that case, 1, 3, 3, 1. I'll write them up. Look, so probability of me getting all 3 yellows. Only one way of that happening. Probability of me getting 2 yellows, so that's yellow, yellow, not yellow, which is this one here. Look, there's 3 different ways of that happening. The probability of me getting yellow, not yellow, not yellow. There's 3 ways of that happening. And the probability of me getting not yellow, and not yellow is 1. So it's the third line. And the second one is, this all relates back to the stuff we did on the binomial coefficients. Okay. You need to know the formula is in the formula book, but you do need to know how to manipulate it. I've got a couple of questions coming up here. So this is where it all comes from. Somebody sat down, looked at a tree diagram, and went, hang on a minute. Yeah, I can see what's going on here. Okay. So here's the formula that you guys need to know. So you've got the x is approximated by the binomial distribution. N is the number of trials. P is probability of success. So if I want to calculate the probability that x equals some sort of value, which the calculator is doing, it's n, choose x, the number of trials, choose that value there, the probability of success to the power of x, 1 minus p, which is effectively going to be failure, isn't it? If that was 0.4, it's going to be 0.6, n minus x. Now the powers, if you have a look, will always add up to n. That's something we found with the binomial expansion. So for instance, if I had probability that x is equal to 4, I'm just need to make myself a distribution here. So x tilde b, let's have 20, and don't know whether it's decimal or not, let's have it as 0.1. Probability that x equal to 4 is going to be n choose x, so that's 20 choose 4, 0.1 to the power of 4, so it's quite a nice pattern to follow. Probability of 1 minus p therefore is going to be 0.9, and it's going to be n minus x, that's going to be to the power of 16. Okay, and then I would work that out. I would do 20 choose 4, probably do it on my calculator, unless it specifically asks me to work that out. That's going to be calculator, that's going to be calculator. Okay, so that's the formula. The next slide is going to be working with it. Okay, so here we go. I've got a binomial distribution there, and this time I'm going to use the formula to calculate. Now, I've tried to keep the numbers quite short on these because they are going to take a while. So this first one here, if I'm just using the formula, it's going to be n choose x, so 8 choose 5. Okay, so I want to win the game 5 times. So then it's going to be 0.35 to the power of 5, 0.65 to the power of 3, and then I'm quite happy for you to type it in your calculator, so I'll grab the calculator now. So I need to go back to the menu, and you need to then go to option. We're going to looking for a probability function, so we're going to go to prob. So it was F6, F6, then F3 to prob. NCR, let's go to the front, so it's going to be 8. Choose 5, I'm going to put that in a bracket a second. Multiply that by 0.1, to the, sorry, 0.35. Think about the last question there. 5. I'm putting time zones in because sometimes with the calculator, particularly these choose bits and pieces, it doesn't quite like it. So I'm just going to be sort of over the top with writing it out. 0.65 up to the 3. And there you go. 0.0807. Well, I'll take there's an 8 around it. So that comes out as 0.0808. Okay, now for this one here, the one underneath, this is effective me calculating the probability that x equals 0 plus the probability that x equals 1. Now I'm not going to write these out because it's fairly simple to do. Grab a calculator and feel free to have a look at it. I'm just going to be wasting your time otherwise. These are dead easy to work through. This one here, probability that x is greater than 7 out of the probability that x is equal to 8, because they're the same things out there, because the maximum I can have is 8. Probability that x is greater than or equal to 6 is going to be probability that x equals 6 plus probability that x equals 7 plus the probability that x equals 8. Now when I did my A-levels, you have to sit and do each one of these with the formula, but you're going to save so much time using the calculator you guys have got. Okay, hopefully that makes sense. So the formula is in the formula book. You just need to know how to use it. It is quite nice and simple to use. Okay. Now, one last question I've got for you. Now, what we've got to remember is that the exam board, or whoever writes the questions, know which that you can do this on your calculator. So they need to come up with questions which make you think and allow you sort of not to use your calculator, which sort of defeats the point of it, but never mind. Okay, so here's a question. This is a really, really good question. Write it down, and I'll show you the solution. So I've got a tennis player going to play 8 matches. Each game is independent, so I need to satisfy the binomial. The probability of winning is P. And we're going to have X as the number of matches. And it is known that the probability of the player winning 5 matches is 4 times the probability of the player winning 3 matches. Okay, we're going to try and calculate P. So this is one of those questions where if I just throw you into this, you know, oh my word, what is going on here? This could be quite difficult to get your head around. Now, as you can see, this is going to be quite difficult for me to do my calculator, so I need to use the formula. Okay, so we've got x tilde b, np, so n is 8, p is p. Let's just check the binomial is satisfied. Do we have 2 outcomes? Yep, the win or lose. Each one's independent, yep, because it says. Probability of success is the same, yep. And we have a fixed number of trials, I mentioned that one. 2 outcomes, probability of success, independent, yeah, I think I've got more. Okay, now what it does tell us is that the probability, in fact let me rub that out, I know I'm going to need a bit of space for this question. Okay, it tells us that the probability of winning 5 matches is equal to, it's 4 times the probability, 4 times probability that x equals 3. Now in my eyes, that's the most difficult part of the question. Turning this into maths is the most difficult step, because once this step's in, you can sort of see what I'm going to do. Now I'm just going to dive into the formula. Okay, so it's going to be 8, choose 5, multiplied by p to the 5, 1 minus p cubed is going to be equal to 4 times 8, choose 3, p cubed, 1 minus p to the 5. Okay, it looks really, really difficult to cope with, but I promise you it's not going to be that bad. First of all, let's do the easy stuff here. 8 choose 5. Grab a calculator. I get that as 56. Let me just double check it. Fairly sure it's right. 8 choose 5. There we go. I may as well calculate 8 choose 3 on here. 8 choose 3, which is 56 as well. Okay. So we're going to have 56 p to the 5, 1 minus p cubed. Now we know that is 56 times 4 is 224. P cubed 1 minus p to the 5. Now on here, we know a couple of things. We know that, for instance, p is greater than 0. I mean, p might be 0, but it wouldn't make any sense here. In fact, if p was 0, in fact, it would satisfy it. But in this case here, p is not going to be 0. So, first of all, let's divide through by 56. So, p to the 5, 1 minus p. I mean, I could have cancelled them off first step, but it's always better to show everything. P cubed 1 minus p to the 5. So we know that p can't be 0, so we can divide through by p. I'm just going to write that p not equal to 0. Make sure you do that, particularly in these new spec questions. So divide through by p. So p squared 1 minus p cubed is equal to 1 minus p to the 5. Also, we know that p has to be less than 1 as well. So 1 minus p then, that can't be equal to 0 either. And actually p actually can't be equal to 1 either. Okay, looking at this particular context question. So actually we can divide through by 1 minus p cubed. So we end up with p squared is equal to 1 minus p squared, like that. I think there would be a temptation for some students to multiply these out. There'd be no need. It would be quite difficult, and you'd know by the number of marks as well. So I'm dividing through to get this as simple as possible. Now, at this point here, some of you might want to pause the video and you can manipulate this. You can expand that bracket, rearrange. You can do that if you want. But what I'm going to do is I'm going to actually square root both sides. Now, the reason I can do that is that we know that p is positive. Okay, so I can just take the positive root of both sides. Otherwise, if you want to, if you're not happy with that, expand this side and just equate. So I've got p is equal to 1 minus p. And I've just noticed something. I bet some of you are going mad, going, Aaron, what are you doing? I completely agree, and my apologies if I've gone too fast. I've dropped to 4. So if I square root both sides now, that 2 appears. There we go. My apologies for that. I was going to pause the video and go back and change it, but 33 minutes and I don't really want to. So p is equal to 2 minus 2p. Say my apologies for that. Should have noticed it. I even said it, I think. 3p is then equal to 2. And then p, lost my pen, p is equal to 2 thirds. Okay, so it's not a bad little question to do. Obviously the algebra is quite advanced. Let's say a lot of the time at the beginning of the course it's all about the algebra. How well can you expand? How well can you manipulate? Make sure you can do that. Any questions about it, give us a message on Google Classroom, or anything that does make sense, let me know. After this then, you are finishing the rest of the exercise. It is quite a long exercise, so I would normally take 2 lessons over this in class. be able to master the binomial distribution. If you want any more practice, there are lots and lots and lots of questions online. Maths and physics tutors, absolutely thousands of these. Thank you for watching, and best of luck.